Example of trinomial factoring. The only difference between this one and the last one that we've done is even after we've pulled out the greatest common factor of this trinomial, the lead coefficient is still not going to be 1. We're going to use the technique from the last section, or the last example, but we're going to add in one more little step to complete. Before we really begin, though, it is very important to pull out the greatest common factor. A couple things that will happen is it'll definitely make the numbers smaller, and it'll make the problem a little bit easier to deal with. Alright, so the greatest common factor between 24, 2, and 12 is the factor 2. And then what's left behind is going to be 6x squared plus x plus 1x minus 12. Alright, to factor what's left in blue, it's still a trinomial. We're going to use that breaking apart of the middle term into the factors that make up some product. In this case, what we're going to do is multiply the first number, the 6, times the last number, the negative 12. And then we're going to kind of ignore that it's negative right now. So just, 6 times 12, which is 72. This is the number we're going to work with when we say, what are the factors of this that give you the middle number? So our language is going to be the factors of 72 that subtract up to a positive 1. Remember, there's this 1 sitting in front of the x. Alright, so I just need factors of 72 that subtract up to 1. If you don't know it off the top of your head, the best way to deal with this is to break 72 down into all its possible factors. So 72 could be 1 and 72. Well, obviously that one doesn't subtract up to 1. 2 and 36. 3 and 24, oops, 4 and 18, 6 and 12 would be the next one. And then finally we're going to get up to 8, and its factor would be 9. By going in sequential order, you're guaranteed to get all the factors. So always try, like notice I skipped over 5. I know 5 doesn't go into 72. And the same thing for 7, I skipped over it. But once you get them all in sequential order, you're not going to miss any. And this is the one that we're going to be looking at. It is the one where if the factors of 72, if I subtracted them, will give me a 1. So I'm going to take this middle thing, and I'm going to split it up into an 8 and a 9. And the order of the numbers is irrelevant because of that commutative property of addition. What's important is what sign each number gets. I need a positive 1. To subtract, one of them is going to be positive and the other one has to be negative. Well, since I want a positive one, I'm going to make the bigger one positive. And they both, again, have to have that x. So when I add them together, I do get that positive 1x. And then again, just like before, bring down the first term, bring down the last term. We didn't play with those. This 2 out front, I'm kind of going to ignore for a little bit, but I got to remember to bring it down into my answer. It is part of the answer. Alright, so let's group the first two and see what we can pull out. The greatest common factor here is 2x. Left behind will be a 3x minus 4. And then if we group the second two terms, it's positive, so I'm going to pull out a positive, whatever it is. Between 9 and 12, it looks like a 3 will come out. That'll leave you behind with a 3x and a minus 4. Negative 12 divided by positive 3. So I can take out that common factor, the 3x minus 4, and leave behind the 2x and the plus 3. And again, don't forget to bring down that factor of 2 because it is part of the answer. So this whole thing is the factorization of 12x squared plus 2x minus 24. If you multiplied it all back together, that's what you're supposed to get, what we started with. And we're done.